describe the transformation and the notation of your choice. So remember, when we do this, we have to make sure we go from our pre-image to our image. So the ones without the apostrophes or the primes to the ones with the primes. So in this case, do we have to go up, down? Which way? To get from here to there. Someone said it. Down. How many do we have to go down? Perfect. So we went down 3, and then we have to go to the right. How many? 2. Okay, that's the verbal description right there. Down 3, right 2. Perfect. If we wanted function notation, we would write x is right adding or subtracting to our x. Adding. Nice try. And then down means add or subtract to our y. Subtract. Okay, so then our vector notation would just be 2, comma, -3 in those arrow looking things. Okay. Sweet. So reflections is what we are talking today about. This is our second of 3 different transformations that we practice in this class. Okay. So the reflection is a transformation over a line M such that if P is not on line M, then it's the perpendicular below that. We don't need to know that. Okay. So if the point is on the line, that just means P prime is also on the line. Okay, because you can't reflect it over when it's already on it. Okay. Q is the same distance away from that line. Okay. So a reflection is an isometry, which means it preserves distance and angle measures, and sends lines to lines, rays to rays, etc. So your shape should remain the same, is all this is saying. It's an isometry. So let's look at this practice real quick. We're going to do a little proof here. So we're given that P is equal to P prime. So P equals P prime. And M is the perpendicular bisector of QQ. So M is perpendicular bisector of QQ prime. So we literally just copy our givens down for that first line there. Well, what does perpendicular mean? It forms a what type of angle? 90-degree angle, a right angle. So if it's the perpendicular bisector, that means the angle QRP is congruent to angle Q prime, R prime, P prime. Oh wait, not R prime, but just R. P prime. Q prime, R, P prime. That's what it's supposed to say. Okay, so the bisect part, remember if you're in science class, you dissect something, you cut it, right? Bisect means cut into 2 equal parts. So that means that QR is the same thing as Q prime R. So QR is congruent to Q prime R. So we have this pair of sides, this pair of angles, and then by the reflexive property, I can say that RP is congruent to RP prime. because it's that same line. So these two triangles are are congruent by, if we label it out, it's SAS. And then what we're trying to prove goes last. So PQ is equal to P prime Q prime. Because, does anyone remember this fancy thing?
Was it C?
Yeah, C, P. Perfect. CPCFC. Corresponding parts of congruent figures are congruent. Just, you're not going to have to recreate that on your homework. That's just me showing you the proof of why this works. Okay. So we are given these 2 points, okay, and we're going to reflect those points. So H is at 2, 2. So we go to 2, 2. This is our H. Okay. It tells us to reflect in the x-axis. Where's our x-axis? Is it the vertical one or the horizontal one? Yeah, the horizontal one. So this, I'm going to draw the line that I am reflecting over. It's helpful, I promise you. Phones and Chromebooks should be away. Put away. So if I want to reflect over this x-axis, what I do is I count how much it takes to get to the line. So I go 1, 2, right? And then I go that much away from the line. So I just go 1, 2 away. So it's the same distance away. So you go count how many 2, go that many away from the line. And that's H prime. Okay, any questions on that? Okay, so for G is at 5, 4. So 5 on our X, 4 on our Y. Okay, that is G. Okay, we want to reflect in a line Y equals 4. So if you don't remember how to do Poivux, here's a little recap. When it's Y and equals a number, that means it's a horizontal line. Okay, so at 4 on our y-axis, we put that horizontal line. That's the line of reflection. Hey, it's on our line. What does that mean? Yeah, you don't have to move it. It's on the line already. So this is also G prime. G and G prime are the same because it's on the line of reflection. The Vux part stands for when it's X and a number, it's vertical. Because we'll get there on this next part. Can you wait until after notes? Thank you. So we are going to graph the reflection. I don't know why there's a random C there. That just happened. So A, we have at 3, 2. So we have to plot that point first. 3, 2. That is A. We want to reflect it over what? The y-axis. Our y-axis is right here. So we count the amount it takes to get to the line. We take 1, 2, 3 to get to the line. So we have to go 1, 2, 3 away from the line, and that is our A prime. Okay. For B, it's at -5, 6. So -5, +6. Put a dot there. That is B. Ooh. Oh no, we're fine. I thought that said y equals -5. I was like, So we want to reflect the line over x equals -5. So -5, our x-axis is here, or our x is a vertical line. So we go straight up and down. So what do we know about B prime? It's the same as B's because it's on that line. Okay, you guys try the next one on your own. So plot C, find your line of reflection and reflect it over. So what you guys should have done is we want y equals -3. Well, we know from earlier y equals a number is horizontal. So on our y-axis at -3, put that horizontal line there. Okay. Then we have to reflect it over that line. So it's 2 above. So we have to go 2 below to get C prime. So your C prime should be at -4, -5, if done correctly. All right. So we're also going to touch on symmetry today. Symmetry is, so have you guys ever, like, when you were little, you would fold the paper, do half of a heart, and then cut it out, and then it made a whole heart, right? And that's the line of symmetry, right? So here is what we're talking about, the same thing, okay? So it can be mapped onto itself. That means just fold it over, and it'll match up perfectly. So hexagons can have different lines of symmetry depending on their shape. So this one, kind of an odd hexagon, right? This is one line of symmetry right here. Because if we folded it directly in half there, both sides would match up perfectly, correct? Is there any other line of symmetry on this one that would line up perfectly if we folded it on? Not on this one. Okay. This one, I see a line of symmetry here. So this is one line of symmetry. Okay. Is there any other line of symmetry where it would line up perfectly if I folded it? I see one more. Yeah. Horizontal across that middle right here. About. Because if we folded it straight up, that would be. Is there anything else? Not on this one. So this one has two lines of symmetry. Okay, this is known as a regular hexagon. Okay, that just means that all of the sides are the same and all of the angles are the same. Okay, so a regular hexagon, we can split it right here. Has one line of symmetry. Okay, see if you guys can find any other lines of symmetry and draw them. And I give you 30 seconds. How many lines of symmetry did we get? Anyone? Shout out a number. There's no wrong answers. Well, there kind of is, but someone found 2. Sweet. Anyone find more?
6.
Someone found 6. Did anyone find more than 6?
4.
No. 4. Okay. So the most we found was 6. Let's see if we can find all 6. So we found one here, right? If we go through the middle of these sides as well, that's another line. So there's 2. Okay, there's also one right here. That's 3. Okay. Where are the other lines of symmetry? Yeah, through the what's called the vertices. Okay, so these little points here are called vertices. So if we go directly across from those, there's one, there's another, and there's another. So that is a total of 1, 2, 3, 4, 5, 6 lines of symmetry. So whoever got 6, good work. Okay, how many sides does a hexagon have? 6. How many lines of symmetry does it have? 6. So if you are asked about a regular polygon, the number of sides is the same number of lines that it's going to have. That's going to be helpful in your assignments.